All right, so today's presentation is going to be on the model of continuous delivery. I'll talk a little bit about DevOps holistically, but we're going to really focus on continuous delivery and dive into how to implement it, what it looks like in Visual Studio Team Services. Who's using VSTS right now? Who's using any type of build server? Okay, awesome. So we're going to get into every piece. We're going to have a deep walkthrough, talk about the process of continuous delivery, and blaze through it in about 45 minutes. If you'd like to write down my email address or Twitter, I love when folks get in contact. Happy to answer any questions. The email address is on the screen. And let's dive in. So I'm going to sit down here. I'm going to have a few overview slides, and then we'll jump into Visual Studio. So you can't really see this, but this is the overview of continuous delivery and all the pieces in it. We have a process of taking a change in source code and getting it all the way to production and having multiple venues for feedback coming back. And then we have the actual architecture of the environment itself and how the application lays on top of that environment. I'm going to go through each piece one by one. And first off, we have our overall environment, just to give us the infrastructure to make all of this possible. Because, again, whether it's one person, two people, 10, 20, 100, we have people who are making changes to the source code and software. And source code includes scripts and database schemas and every artifact that could possibly modify the behavior of the system in production is source, okay? And so the basics of a DevOps environment includes your version control, your IDE, Visual Studio Team Services, which serves as the build server and the deployment server. We have pull requests as a process, which I'll touch on a little bit, between your source control and your build automation, and then we have monitoring for the actual environments that are installed with our automated deployments. So piece by piece, we go to the first piece here. There's some scenarios that we want to make sure are covered. One is a private build where if you're at your workstation locally, you and all your peers, you want to have some sort of script that even before you push code up to your shared Git repository, you want to make sure that that private build script is green, that private build script works. And that includes compilation, running all of your fast tests and whatever checks you have that are quick. Then your continuous integration build, you want static code analysis in there. You want to package your release candidates. And I'll go through each of these key scenarios here that are on the screen as we walk through each piece of it. But holistically, what we're looking to do is move our changes to production and not introduce problems. Because we all know, anybody who's been in this industry for more than a day knows that when we deploy things, mistakes happen, sometimes a bad file, and then the system doesn't work. And so we're looking to increase quality, reduce problems of any kind, and put static code analysis as the third in the list. I think I was having a phone conversation with Capers Jones a few weeks ago. He's published a lot of research on quality and productivity, and static code analysis by far outperforms automated testing when it comes to defect removal. And so if you combine automated testing, static code analysis, and then human inspections, that can get us to 95% defect removal, which is what we're looking for. We want to go to production without defects, go to production without problems, remove problems. So let's dive into each part of the process. And then we're going to move over to Visual Studio and go into our build server to see how this is set up. So our private build, some of the key things, we want to run all of our automated unit tests. We want it to be no more than 10 minutes. If you can get it down to 5 minutes, that's great. We don't want any one piece of it to start to be a time hog. And when something takes 30 seconds in a private build, that starts to become a time hog. And from a source perspective, here's a key thing. Everything that belongs to the application should be stored in source control. Everything that belongs to the application, because if it's not stored in source control, then it's not versioned together. And anything that's not versioned together is a risk. Now, from a practical standpoint, your development environment, Visual Studio, is not in source control. And so that poses a risk. And we see that risk sometimes when we get to a new version of Visual Studio, and then we go back in time and pull a commit, and then it doesn't work. There's some compatibility issue. So that risk exists. Anytime anything is not stored in source control, that risk exists. We accept that with Visual Studio and some big things like that. Grab some pizza and come on in. Welcome, welcome. And but the small things, there's no technical reason why every single artifact needed to build, test, and deploy the system cannot be stored in source control. I'll give you an example in the NPM community for Node, and arguably NPM as a package management technology has popularized the notion where lots of people are talking about it now, and of course Nougat on the Microsoft space. But NPM, the packages, they just go on for days. And so if you just Google the conversation, you'll find lots of people talking about, should I commit my NPM packages, or should I just go to the package manager and download them fresh every time? And you see arguments on both sides. But then when you're starting an application, and there's not much pain either way, but there's people who are sharing their experiences where the application gets larger and larger, and there's lots of packages, lots of versions going on, and not storing them in source control. They're documenting all of their pains, and then they store them in source control, and then their repository gets bloated. And so one of the new Git features, which is a shallow clone, is a direct response to, okay, we need to store everything in source control if we're going to reliably have something to build and deploy. But I don't want to get the full history because that's just a lot of data. So there's a new Git feature. And that's not new, but the shallow cloning of Git is a response to package managers and the dynamics that go into that situation. So, but if you're not going to store something in source control, make sure you have a really good specific reason and talk about it as a team. Okay. All right. After your private build, you'll commit, push your code up, and then our continuous integration build happens. Now, show of hands, who's building software on a day-to-day basis? Just for a quick. Okay, about 2/3 of the room. And so the rest of you, just a quick, who didn't raise their hand? What kind of roles do we have represented? Just shout it out.
I'm in training. So.
Training? Okay. Or were we just, our arms were tired because we had some pizza? So everybody's a developer here?
I do.
Okay, awesome. Okay. Okay, I'm glad to know the audience. So with the continuous integration build, some of you might already have a continuous integration build, but that's the first step to continuous delivery. Now, continuous integration goes back, was largely popularized in the .NET world by cruisecontrol.net, which was ported from a Java product called Cruise Control. And that was 2005-ish, I think, somewhere in that neighborhood, 2004 maybe. And it's the notion of, okay, if we're all going to be making changes to a source code repository, we need a server who's constantly getting them running the same script and running a process that's called a build process to validate that the changes from everybody didn't break anything, that we're integrating the changes from multiple people, and that's where continuous integration came. Now, the concept has been extended to integrate with dependencies and other services and even other companies, but it started just trying to integrate changes from multiple people. And so we've extended it in continuous delivery and made integration holistic, where any kinds of variances in our environment can cause problems. So Visual Studio Team Services is going to manage our build process, and I'll show you a working example of that. And then as we go along, our continuous integration build produces a release candidate in the form of a Nougat package. On the Microsoft platform, the Nougat package is the standard package format. Now, from a technical perspective, you could use a zip file. There's nothing technical that holds it back. And actually, a Nougat package is just a zip file with a different extension and a manifest. So essentially, you have these zip files in VSTS package management. It's a special zip file called the Nougat package. And we want to store what we're going to deploy. And so if you're familiar with artifacts from lots of build servers, it can store any, build servers can store any artifact, any file. But when we're transitioning from a continuous integration build to a deployment pipeline, we want to have a good release candidate package, and I'll show you what ours look like, and store them and version them and stamp them with a version number. Let me keep going real quick so that we can get to demo. Okay, VSTS Release Manager orchestrates our deployments. And there's 3 different levels in the smallest of small. There's your dev test environment, your UAT or staging, and production. There's 3 environments. You'll never get fewer than 3, and I'll go into each one, but oftentimes you'll have more than 3, okay? So the first environment is the first time you actually try to deploy your software, whatever it is. It could be a simple website, could be a really big multi-service system, but your first environment, I'm calling it dev test, you call it what you want. The first environment is no humans allowed. It's only for automated testing, okay? Whatever automated tests you can cram into a test suite that is appropriate for deploying the software, running some validating tests, and then you know even more so than just running your continuous integration build, that the application actually works when deployed, okay? So that first environment, we want to deploy, we want to run some full system tests of varying kinds and make sure that they all work, and then we want to throw away the environment or install the next build and just keep churning. So if a person tries to get on this environment, they'll find that the application keeps getting pulled and redeployed out from under them. So no humans allowed, pure automation. That's the first environment in a deployment pipeline. The next one is your manual test environments. Now, you should have a minimum of 1. You should always have 1, and oftentimes you're going to have plenty of them, okay? But in the smallest of small deployment pipeline, you have your automated test environment, which is environment number 1. Then you have your manual test environment, and then production. So with manual test, it could be you could call it QA, you could call it UAT, you could call it staging. All these environments need to be production-like, but you have at least one of these manual test environments. I'll go into a little bit deeper. And then lastly, we have the production environment. We want to make sure before we do anything here, make sure your backups are current. That's always, even with the new DevOps techniques, it doesn't negate, the old, let's stay safe and make sure that our backups are current. There are some cases where some companies have automated deployments all the way through production. I'd be surprised if many people in this room actually want that. Most people in the industry want a gated approval to go to production, where there's a business decision to say, okay, we have the ability to go to production. Let's click some sort of button, somebody authorizes it, and let's actually do it. After you've implemented continuous delivery, you'll probably want to modify the deployments to be 0 downtime deployments, because then it allows you to deploy during business hours. If you have downtime, well, then you need a maintenance window. And if you need a maintenance window, you have to pick the time when you can actually say, nobody can use the software, okay? And if we're going to a more flow mindset, which is the first way of DevOps, which is flow, we want to not have to block and wait on any kind of events. So that's just from a mindset perspective. Okay. And then finally, well, we're not going to demonstrate today, but there's a concept of deployment rings once you start to scale, where you have multiple instances of a particular system. And you can implement a deployment ring is where I'm going to deploy to a certain type of my customers, of my users, and We can either do it via data flags, we could do it via environments. Salesforce, actually VSTS is a system that uses deployment rings because the system can only support so many accounts on one particular cluster. Same thing if anyone's familiar with Salesforce.com, there's not just one deployed Salesforce. There's many, and your account might happen to be one. And so if they're gonna rev Salesforce.com, they're gonna use deployment rings and choose one at a time. And that if some problem slips through, deployment rings is a concept that prevents all of your customers from experiencing a problem if one slips through to the first ring that you deploy to. Okay, so that's the last of the slides. I want to jump in and give a quick demo of an application that we're going to be working with. And it is in, no, I do not want to end this meeting. Okay, in Visual.
I have a quick question, Ivan. Is any of this process made better in the cloud versus on-prem, or is it hybrid, or is it pretty much the same in any type of infrastructure?
So I am going to show some of that. I have to say that the cloud does make so many things easier. When you're using, specifically in Azure, if you're using the Azure PaaS services, they're very easy to provision and configure. Whereas if you're using Windows servers, they're just a little bit harder to automatically provision and configure. Now, once you have it working, it's working, but it is just that little more friction. The Azure PaaS services are designed to be provisioned completely in an automatic fashion. So it does have some advantages. This particular pipeline has both, and I'll show you in a minute. We have a very simple web application, and I'll pull it up and actually show what that is. Move this over to the side. Okay, we have a very simple expense report system, and if I log in as myself, actually log in as, move this guy out of the way. I have multiple instances here. All right. Very simple 3-screen web application. And if I log in as myself, I can create a new expense report, and I can say I spent $12 and submit the expense report to my boss, which is Damian Brady, apparently, right here. And then we submitted the expense report. I can search for the ones that I just submitted. Here's the one I just submitted. I can check on the status of it. Okay, looks like it's still waiting. So simple, nothing of a web application. From a Visual Studio perspective, it's ASP.NET MVC. It's .NET 4.6.1, which it is also .NET Standard 2, but full framework 4.6.1. It's using Entity Framework Core 2 on top of SQL Server. And so we have a database project that has database scripts, so it can be fully automated. This application actually has a lot of history. And so we're going to see what it takes to deploy this, including deploying the database. All right. So many applications out there are ASP.NET Web Application, SQL Server Database, and probably a backend job of some sort. And as it grows larger, website gets larger, or maybe a second website pops up that's web APIs, or maybe we have a second Windows service or scheduled job. But that type of structure tends to be very, very common. And while desktop applications are still out there, more and more applications are ASP.NET. It kind of now dwarfs the desktop applications that are being developed currently. So we're not going to spend a whole lot of time inside Visual Studio, but we're going to jump to VSTS and see how this type of application is set up for continuous delivery. The one thing locally I will show is the source tree. So we have some helper functions. We have a PowerShell build script, which is our private build. And if I just click to build.bat, then locally it'll run a private build. It's going to run MS build, and it's going to run in unit, and then it's going to run our database migration, which happens to be Alias SQL, but it could be Redgate Ready Roll, it could be Roundhouse. There's a number of migrator tools that are good these days. I'm not going to wait for that to finish, but that's a private build script. Notice that there's no solution file in this top level of my working copy. Okay, you see there's my Git directory. There's no solution file. Inside our source directory, SRC, which is a very common convention, that's where our solution file is. Okay, when you're running in build environments, it's often very convenient to have your solution file and all the projects just one level down from the top, so that you have a place for your build automation and various scripts and helper files. If your solution is right at the top, then everything gets bundled together. So that's just a little tip there. Okay, in our Visual Studio Team Services dashboard, we can see 2 deployment pipelines that we have, the status of our integration builds. Notice that we have some build failures there, and I'll go into why, and some other stuff. Okay, if I go to the build, we can see the history of the builds. Should go into the build configuration here, and we have some builds from actually the branch where this application was converted from in Hibernate ORM to EF Core 2, and you can see that pull request got merged into master. And if I just let me just go to this latest build. From a time perspective, I'm not going to kick off the orchestration again, because then you have to wait some number of minutes for the build to run. You have to wait some number of minutes for each build. So I'm going to walk you through just the most recent one. And so I move our video here. Sorry about this. Okay. So we have our build logs. If I want to scroll down, okay, I can see that I have deployments hanging off of this particular build configuration. And if I scroll down here, I have an Azure PaaS pipeline, which I'll go into detail, and then I have an on-premise pipeline. So I have one continuous integration build that's kicking off 2 types of deployments. Okay, and with VSTS, that's possible and very easy. So if you are thinking about moving to Azure and you currently are on servers and VMware or even physical, you can set up an automated deployment where you are, and then you can set up a separate pipeline testing out a new environment that you're building out. And then once it's online, once it's ready, you can just switch over. Okay, that's one capability that you have. Let's go and just before we come out of the continuous integration build, let's show the tests. So if I want to see all the tests that are passing, I have 82. I can dive into each one of them directly. This build took 6.7 minutes. You don't want to go over 10 minutes. You don't want to go over 10 minutes. And let me show you what this CI build is doing in VSTS. And again, this is Git source control that's hosted in here, but it's kind of irrelevant where it's hosted. It could be on GitHub or Bitbucket or anywhere. But what's interesting is that this configuration does not require us to maintain a build server. It is a completely hosted. Build agent, build configuration using the built-in agents that they spin up in the cloud. So when some source changes, VSTS spins up a VM somewhere loaded with Visual Studio 2017, all the compilers, the SDKs, everything necessary to build the software, and then it runs essentially what I have specified here. Now, one interesting thing is it does not include SQL Server of any kind on the agent. So most of our software includes a database, wouldn't you say? And so we have to take care of that for ourselves. So the first thing in this build configuration to make it so that we don't have to maintain anything, and by the way, for speed, I disabled this last bit just for this presentation, but I could easily I could easily enable it right here. It is dropping the resource group in Azure. I am creating whatever I need for this build to run in my Azure subscription, and then a couple minutes later, whenever it finishes, I'm just dropping it. So in that way, I don't have any VMs hanging around that I have to maintain. In the cloud world, any VM that you have to maintain, which includes security patches, which includes configuration changes and upgrades. And so if you can have environments where you create them when you need them, and then you throw them away when you don't, then it completely changes you need to care for your environments, but you care for them by creating new ones, slipping it in there, and then dropping the old one, rather than going into the existing VM, changing something, possibly remote desktop. So let me just go step by step in what this integration build is. We're going to create the resource group in our Azure subscription. Here it is. We have tasks that we can configure here. It is a linked artifact, but we're taking care not to put too much logic in VSTS in the build script. So notice that the template is an ARM file right here in our source. And if I go to source/database, we can see the ARM file right there. It is in source control. So if I need to change some setting about how the SQL Server database server is being created, then I can just change it in that file, okay? And then I'm passing in variables here. That's what this PowerShell is.
And where are those variables stored?
Oh yeah, sure. I can flip over to the variable tab, and we can see that we have variables here, and we also have variable groups if I want to share them between build configurations and release manager. So one of the variable groups that I have is the testing database, and so database resource group name. I want to make sure that the resource group names are unique, and database server, and then a database user. The database password is secured here so that it's enter only, no one can get to it. All right, let me go back here. Okay, so we're going to create the database resource group with the database server in it. Then we have to do one more task just to sniff what the newly created name of the database server was. Just that's the way the provisioning works. And there's a little bit of PowerShell to do that. Then we run our build script, which is the same build.bat file that we ran as our private build here in Windows Explorer. Build.bat. Okay? All right. That does the MS build process, which does our compilation. It injects a version number into every assembly, and it runs our unit tests, it runs our integration tests. And so once that is done, then we can drop our build database because we don't need it anymore. And so if you look at what Azure charges you, it's like 1 cent, each time you run it. So the alternative is maintaining your own build server, loading the VSTS agent on it, and then you've got a computer that you have to keep up and running. This is just so automatic these days. Then we're going to publish the test results. So InUnit kicks out some XML files, and we need to link those up. And then we want to copy all of our artifacts to save them and get them ready so that we can push them to the built-in Nougat server, which in this case is called package management. Then we use a Nougat push to take all of the new package files and push them up. We have our feed located here, and then it's done. If I switch over to packages here, then we can see the 4 different components of our application. And they're all versioned the same. You can see that we have version 189, essentially 3.1.189. We have the UI, which is the MVC application. We have the SQL Server database, and we have 2 others. We have our integration test suite, which has some routines to help seed a testing database that are useful in our first-line automated test environment. Then we have a smoke test component, and this is another test suite that is designed to run against the first dev test environment in a fully deployed manner. and execute full system tests against a deployed instance of our application and run through those tests. Any type of test suite that you would design, you'll likely, if you don't bundle it with multiple test suites in one package, you may elect to have it packaged as a test suite, because then you can deploy the test suite somewhere. You open it up, you kind of install the test suite, most of the time just by copying files, and then you have a command inside there to execute the test suite against a particular application deployment. So, but the application itself is UI and database, but notice the version numbers are very important. And if I were to open up one of those, if I were to rename it .zip, extract it, and go to the DLLs, look at the properties, I would see that version number stamped in every single one of those DLL files. And that's important. We want to version everything together. Okay, so if I then go to my release manager, I can see my history of releases, and I can see that I have two pipelines: the Azure PaaS pipeline and the on-premise pipeline. And we can see sort of our history. And let me go through the on-premise one first. Okay? So if I actually, a little demo here. We have 189 that is deployed to our, let's go to it. Deployed to our test environment, is deployed to staging, but it's not yet deployed to production. Okay. So there is an approval pending, because I've got this particular build configuration gated. I'll walk you through the steps that it happens, but let me go to prod. Prod web. Here we go. Let me correlate. Okay. So if you can see here, right here, this version 3.1.187 in production, that's the version. And by the way, this stuff at the bottom is kind of debugging text, just so I can, for doing these talks, show what version it is. So 3.1.187, and if I go over to my release, we're 3.1.189. Okay, and so let me just go ahead and approve. There we go. And if I go to my logs here, I'll close down stage test and staging, and in a few short moments, it'll start kicking this off. Automated. There we go. And while it's running, let me show you the steps of this. So this is for on-premise. Now, when you do more of your research, you're going to see a feature called deployment groups get more and more popular. Is anybody using deployment groups yet, by any chance? Nobody? Okay. So there's an asterisk, meaning that it's in preview mode, and so this demo is not using deployment groups yet. Octopus Deploy is a very useful technology for deploying .NET software on top of Windows servers. And so if I go to, if I show you what's inside this particular deployment configuration, it literally is create the Octopus Deploy release and push release number, build number. And that's pretty much it. And so if we go to Octopus Deploy to show the configuration, build. Okay, let's go to actual releases. We can see, the production environment is actually happening right now. 3.1.189. I can look at the logs and, well, it just finished. So if I go back to my production, see it's 187. I'm going to refresh, and look, it's 189. Okay, so we just deployed the application. Now, from a process perspective, on VMs, Octopus Deploy integrates really well with VSTS, and we use various steps to configure the application. For instance, for our database, we deploy our database and upgrade the database schema first, and then we deploy the web application. Now, I'm sure there's quite a few people here today that are not using automated database migrations. And so real quickly, let me just walk through that, because that is a key thing you need to do for automated deployments. And whether you're using AliSQL or Roundhouse or the commercial Redgate Ready role, you're going to have a command line tool, and you're going to feed it your connection string information and say, all right, go to that database, and well, let me show you the command line so it's real for you. All right, here's our private build script, which, by the way, you can get this on github.com/clearmeasurelabs if you want to write that down and get this whole application. So I'm not going to go through every piece here, but go through the AliSQL line. Here's one. The AliSQL is the .exe. We're telling it to rebuild the database, giving it the database server, database name, and path to the database scripts. Okay? When I say path to the database scripts, I mean this particular folder. And it's going to alphabetically run the SQL files in order. So if you run all of these SQL files in order, you come up with the latest schema. But because they're individual SQL files, if you go back in time to a month ago in your Git repository, you're not going to have maybe one or two of those SQL files. And when you run all of them that are there, you're going to get the exact schema as it was back a few weeks ago. Okay, so that's the theory behind it, and it actually provides a mathematical proof certainty that you will never have the wrong version of the SQL Server schema with the version of code that you have. And so, just to show you it could be as simple as, oh, create table. Let's create a role table. Not complicated. Just once you run that SQL file, guess what? Now I have a role table. And could be modifying as well. For instance, when we converted in Hibernate to Entity Framework, there actually were a few minor changes in several tables that we needed to do to the schema just for the best compatibility, things that weren't really necessary in Hibernate, but Entity Framework has some opinions. And so this script is basically, we let the migrations tool say, okay, hey, what would you do with this schema? And it kind of spit out a whole bunch of various things. And there's some checks, but things like, let's see, the schema was using datetime, and of course, to upgrade it, datetime 2 is what the latest recommendation is with the later version of SQL Server and EF Core. And so, okay, let's recreate the table with datetime 2, and so let's create it, let's shuck the data over, and let's drop the old one. Things like that. But whatever you put in the script is what will run. And it can be complicated, could be simple, but the build system just runs the scripts, whatever happens to be in there. Okay, and so this process is doing that. We go back and look at our release pipeline. Let's see if it shows that production happened successfully. And it was right here. That was 189. Yep. So production happened successfully. We saw the version number increment on the website. Now let's go into the Azure release pipeline. And this is 100% Azure PaaS. There's no Octopus Deploy. There's no VMs that are being configured. And we have a 3-stage pipeline: our test environment, our staging environment, and production. A convention that I happen to use is numbering them for the order in which things happen. So you see, 1, 2, 3, 4. You pick whatever convention you like. Okay, so this is the deploy. It has 20, actually a lot more steps. because we're doing it without having any VMs. This is 100% Azure PaaS, 100% cloud. And remember how we talked about the first line environment being no humans only, or no humans allowed, automation only? And so at the end of this, for regular course of business, you can drop the resource group that contains the entire environment because we're creating it from scratch. And so if you think about the cost to have a deployment pipeline, who knows that servers cost money, right? Okay. So if we go to having everything in Azure and using the managed SQL Server that's in there and the web application, the websites that are in there, and using the PaaS services, we can provision it when we need it, and we can get rid of it when we don't. And for a purely automated environment for running various types of test suites, we only need it to exist for the duration of running this particular deployment configuration. And at the end of it, we can literally throw it all away. It doesn't cost us anything. So think about that. You're going to need production. You've already got production. You're going to need staging. Hopefully you have an environment other than production already, and they're used to spending that money. Everybody does, I know. But most people that we work with don't have enough pre-production environments. With this method in Azure, you can have any number of pre-production environments, and it costs you less than a coffee per month. Now, I actually haven't done the math, so maybe it costs you 3 or 5 coffees. But either way, it is so cheap comparatively to just leaving an environment up and running all day, and then at night while you're sleeping. But guess what? If it's a VM that you've configured with your own 2 hands, you're not going to throw it away. And yeah, you could schedule to turn it off and whatnot, but it's very cost effective. So let's go one by one. We're going to obtain the database package first from the built-in Nougat, from package management. And so there's our feed. And I know if you've never done this before, I know this is going fast, but we're going to obtain the database package. We're going to create a resource group in Azure. There's our resource group name right there. North Central US, which is starting to fill up during high peaks. We found out recently. Got some messages on that. And we're going to use a linked artifact to the database ARM. So again, we have a Azure Release Manager file, a JSON file in source control. Let me show you where that is. Our source database and database ARM. Who's seen a ARM file before? 1, 2. All right, let me just show this to you, just so you can kind of see what these files look like. Database ARM.json. There we go. So a lot of this you can, if you're not familiar with it, there is some tooling in Azure where you can create something using the mouse and click around and then export an ARM file and use that as a template and change some things. I haven't met anyone in my life who actually authors these from scratch, so don't feel bad. But essentially, this is all of the bits of configuration that that Azure Resource Manager needs, so that after it runs, you have a database server, a SQL Server database server run by Microsoft that you don't have to care and feed for. Always going to be up to date. Okay. So we do that. Then we have a little bit of script like we showed before to sniff the actual database server that we just created. Then we're going to create the database schema by running a PowerShell script. That is, where is this PowerShell script? You should be catching on now. In our source. So actually, you're more correct. It's not in our artifacts that was packaged from source. So if I go and show you that, what that file looks like, right there behind my video. Okay, so by the way, something that VSTS does is, let me go back here. It automatically puts all of your variables into the current processes environment variables collection. Now, it doesn't do that for ones that you mark secure, okay? So that's an automatic built-in feature. And if you actually do a write host or write it out to the console, one of those secure variables, it masks it in your logs. So it has some features that really takes care of your secure credentials. And so we have to specifically say, yes, I do want this put into the processes environment. I do need it passed. Now, I mean, you could pass it directly if you wanted to, any number of ways, but we're going to grab all of the input, and then we're going to execute alias QL against a particular database server database name with all of our scripts. Okay, so that's actually running against this newly created SQL Server database. Then we're going to obtain our integration test package, because that has a data loader routine that not only is used for our integration test suite that runs with our continuous integration build, but it's also used to seed a new database for our automated test environment. So we have another PowerShell script that's stored.
Source slash.
Yeah, thanks for helping me out. Appreciate it. Everybody else needs some more pizza. Then we're going to grab the package that represents our UI, which is our ASP.NET MVC application. We're going to poke a connection string. This is you always have to take a variable, shove it into a connection string, and so we actually have a PowerShell script to do that. Although I think that very soon there's going to be a built-in task for poking connection strings in web.configs, which you would think would be one of the first ones. But then we're going to, in this particular application, we need to move it because it's a shared connection strings config file. We just move it one directory. Then we need to poke some environment settings. So remember how we have all these settings here? Well, it's helpful to poke it even if they're hidden. And so we're gonna push some tokens into our layout, and then we're going to do the same thing for our database. Then we're going to create the ASP.NET web application in Azure. We're going to lay down the files and actually do the deployment. We can deploy to a slot if we want to. We give it the URL name. Then we're going to start the website. Then we run a little PowerShell to essentially call invoke web request, just to smoke test to make sure that it started properly. Then we are going to grab our acceptance tests, and for the purposes of this demo and the speed at which they run, I kind of disable these here, but it pulls our test suite and runs it against the environment. And again, I have it disabled for the purposes of these demos, but this particular one deletes the ASP.NET application and the database server. It deletes both of those resource groups so that when I'm done, I'm totally done and I get rid of everything. And for staging, it's a very similar process. For production, it's a very similar process. And then we have essentially two parallel pipelines that we can deploy and run, and everybody's happy. So going back to the dashboard that I showed you first, we can keep tabs on our builds, and the bar graph shows how long the builds take. So if it starts to take longer, then you can look into something. And the pipeline on the left is a on-premise or a virtual machine-based environment completely. And the pipeline on the right is 100% Azure PaaS. But every time we kick off a build, we can run both of them to make sure that our application has compatibility with both, because a lot of people are in transition right now. But the important part is that if there's any problems, you want to stop, go back, undo what you just did, get back to stable, and then try to take another step forward. So we're at 12:58, and I wanted to give you a quick overview of how to do of the model for continuous delivery in VSTS. And yes, you can also do this stuff in Team City with Octopus Deploy. if you're in Azure, VSTS makes it brain dead simple to get going. And if you're on premise or if you're on VMware, then you're going to want to use Octopus Deploy. We haven't found another tool that's better at configuring the applications on top of VMs. And then VSTS is really good and forward looking for that, but TeamCity works well as well. We've also heard of people using all kinds of build servers, and if you're willing to go through the effort, you can mix and match all kinds of stuff. But I think the whole industry at this point is getting ramped up on DevOps, getting ramped up on continuous delivery. If you don't have this book, buy this book. It's called the DevOps Handbook. It's a self-proclaimed sequel to the Phoenix Project, and built in collaboration with the authors of the Addison Wesley book, Continuous Delivery, and it goes through all the technical practices of what our community, what our industry knows as the DevOps umbrella. And so the first of the three ways of DevOps is flow. And the industry is really starting to figure out what it takes to flow changes from source control into production in a fast, safe, high-quality manner. And continuous delivery is one of those practices that's aimed directly at flow. The second one is feedback. The third one is learning and experimentation. But there's so much in flow that if you're just getting started, don't try to tackle the whole thing. Read maybe the first half of the book and really dive in. So we're at 1 o'clock. Appreciate everybody being here, and I will hang around and answer some on-premise questions. And I want to say thank you to the people on the live stream. We'll get this recording produced and available, and we'll try to continue to build out our live audience. I think we have 68 people who we have the Austin crew, but then everywhere else. So we've had a really, really fast uptick in this user group, and so it's kind of exciting. So put the word out. And now we'll close the live stream, but then continue on in person if there's any discussion or questions.